will be doing about graphical summaries for one variable only, and we will explain how RStudio can help us get the most common graphs. So by the end of this section, you should be able to know what graphical summary you should use for a categorical variable. You should know it's a bar graph. And I'll let you go through those. Maybe I don't want to kill the suspense. So in the end, just come back, check you can do those, and tick, and you haven't forgotten anything. I've put a marker on the video so you can find this learning outcome. I've put a marker in the video so you can find the learning outcomes, and you can go back there and check that you know everything you're supposed to know. So the statistical package we'll be using is called R, and we will use RStudio as an interface to be able to talk to R and give R instructions. So what we will see is RStudio, which is at the front, and what's doing the calculation in the back is actually R. So there are other statistical software. The most well-known would be SIS and SPSS. Excel is more for smaller data set for non-professional use. And there are others, but the others are non-free and not any better than R and RStudio, so we'll stick to those. So last time we talked about numerical summaries, and today about graphical tools. But you may wonder, why do we need graphs in the first place? We already have these numbers to summarize what happens. Why bother with graphs? Why make things more complicated unless there is a benefit? So the first thing we're going to do is show that there is a benefit in having a graph. Sometimes there are things you wouldn't guess from just looking at the numerical summaries you have. So that's an example. So that's some data. It's just a short extract of what we have, so it's much longer. And for that reason, it's hard to make sense of what it is because there are too many values. So to try to get a feeling of what these numbers look like, the first thing we're going to do would be to calculate the median. And we get minus 0.1. So is that a good summary of the location of the data? And if not, why? So you can actually download this data set and look at it and try to play with it yourself. Well, if you summarize with just one number, which is the median, it's supposed to be the best representative of the set in some sense. But now, if you plot the data, look at what you get. You are really a lot of values here, a lot of values here, and where the median would be, well, there are no values. Okay, so it really doesn't represent things well. So to take home message is that you should always plot your data before you do anything else with it. It's to explore what's happening. So take a look at what you have. And just a word of warning here, when we say plot your data, we really mean plot the original data, not a summary of the data. So see here, if I import this data set, which was called artificial data.csv, I read this CSV file into something called my data, and then I get the summary. The summary instruction will get me the 5-number summary plus the mean. I could get my box plot. And this box plot actually also hides the fact that there is a gap in the middle and that your values are clustered into sets, right? So you don't see it on that. So you should have looked at the original data. This is already a summary. Now, if you look at a histogram, it would be a little bit better. So same thing, you read your file, you put it in something called my data, so you can get the summary again. But then what you can do is draw a histogram of my data, so the original values, and you would get this. So the histogram really shows this pattern that you have your data clustered in 2 sets. So the graph you use is going to make a difference. That's another lesson. First, you need to plot. Second, the original data would be good. And third, how you plot it makes a difference. So why do we use graph? What's the role of graph? So it's really a key step in the analysis. So it's important to use the appropriate graph for your situation, because remember, the goal is to go from data to information. Data would be this ugly big spreadsheet where it's just this bunch of numbers. So it's easy with a graph to describe the main features of the set of data. So I hope you're convinced that we do need graphs. Now, which graphs? Well, it depends on the type of variable we have, which is why we learned about the type of variables earlier. So at this point, we're wondering which graphical tool we should use. We're still dealing with one variable only, so it's going to depend on the type. If it's categorical, we'll be using a bar chart. And if it's quantitative, we'll have an option, sometimes a box plot, sometimes a histogram, right? So the tool, the graphical tool you use to summarize depends on the number of variables, and it depends on whether it's quantitative or categorical. Little by little, as the course go, we'll be putting more and more things in this table, which is also give you a mind map and an overview of everything that happens in the course and everything you need to know. If it's one variable and categorical, that's a bar chart. If it's quantitative, it's a histogram or a box plot. Basically, same thing as in the previous slide on the table, but written with Word. And so, of course, you'll probably wonder, so what about two variable? Well, that's coming. Don't be impatient. Next section. So say you want to produce a histogram of the satisfaction score with UNSW. So you want to get that. How would you produce this using our, in that case, it's called reference notes, because if one day you want to plot a histogram and you don't know how to, you could come back to that. We've put a lot of R code for you in the slide, just ready to reuse. And we're going to use this first example as a way of getting you maybe a little bit less scared of R. And we want to show you that even if you don't know any programming language at all and you don't know R, there are things you can guess. So it's just a little bit like when you learn a foreign language. First, you can read and understand before you can talk. So we're going to be doing it this way. So please look at what's there, and then you'll pause the video. One of the instructions tells R that the bars of the histogram should be orange. And I would like you to find where that is. There is an instruction which tells R what to put on the x-axis. You know, the label on the x-axis. There is one instruction which puts a title above the figure. There's the title which actually draws the histogram. And then a histogram of what? You know, you need to tell R which value the histogram is going to be drawn from. We need a label on the y-axis, this one. So which instruction tells R what to put on the y-axis? And which instruction tells R, you know, which range we want for the values of x. So please pause the video and start writing numbers in there, and I'll see you in a second. Okay, I hope you've been giving this a bit of thought. So, one, what is the instruction which colors the histogram, the bars of the histogram in orange? It's that thing. Let's say, let's color things in orange, right? And it goes inside the histogram. The second one, where do we put the label for the x-axis? X-lab means what's the label of the x-axis? So that's my number 2. And you will need to write this, you know, between these quotes. And so that's some text. Something that puts a title above the figure. Well, the main title. So what you will put in main will be the main title, and that will go above. So it was histogram of satisfaction score. And you can see that's what you get here. So that's going to be your main title. That's going to be your X, the label of the X-axis. Now, we want R to actually draw the histogram. So to draw the histogram, there's a command which probably looks like histogram. It has to be this one. What I'm saying here is even someone who has never seen R can guess which instruction does what, because the names have been chosen, I mean, to remind you of what they do. So a histogram of what? Yes, if you don't tell R what to draw, then it won't know. We want to draw a histogram of UNSW satisfaction. So you said, I want a histogram of UNSW satisfaction, and I want it colored orange. So histogram of what? That would be my number 5. What's the label on the y-axis? So what do you want written on the y-axis? So on the y-axis, you want it to have written number. So it's going to look like that, and it's going to say number here. Okay, now maybe this one's a bit more tricky. We want to represent on the x-axis the values in a given range. So see here we're representing the values between 0 and 10. So that's what we're trying to tell R. Just draw what's between 0 and 10. So x, the limits of x is between 0 and 10. So it's this one. There will be times where you want to show only a specific range of values for x, so you will need to remember this one. So I hope this convinced you that at least Maybe you wouldn't have come up with this R code, but it's not impossible to read it. And of course, we keep reusing things. So just to test that you got better at that, if I give you this, would you be able to predict what's going to happen? So you may want to pause the video for a second and think of that. I would say it's going to produce a box plot. A box plot of what? Of the number of hours people slept. And I predict this box plot will be green because the color is green. Main, so there will be a title above the box plot. And this title will be box plot of the number of hours of sleep for the MATH1041 students. And there will be a label on the x-axis, which will be sleep hours. Okay? Just because it's using the same syntax and the same instruction as the previous one. And ta-dam, I get that. So this is real data we actually collected from the student from a survey. And we asked them, how many hours do you sleep at night? And obviously there was a funny little person who thought it was great to answer 50. And the result of that, we have this outlier, which means we don't see very much on there. But that's the data we had. And it's green, and it's a box plot, and it has the right labels, and it has the right title. So please note that we got this right. Now, something else we may want to do would be a bar chart. And in that case, we have a categorical variable. Our variable is sex, and so it can be male or female. And so we have a bar for it, where it just counts how many males and how many females there are this term in MATH1041. So first you need to load the data where the information is. So you load that. And then you say you want a bar plot. So your data at this point is just this big table, and what you really want to draw is how many males and how many female. So first, R needs to do a bit of work on the data just to create a table with how many male and female. So that's what the table does. So they go pick that from the survey, and then we want male and female written there. So that's what we do. And again, main is going to be the title. And then we have some label on the X and Y axis, and we can decide to color things. Same thing, we put reference notes in that case to mean if one day you need to draw like a bar chart and you're not sure what the R code is, well, jump back to this slide. You know what? I'm going to put a little marker so then you can just go in the video and find it. Or even better, you go in the PDF, you do Control F and bar chart, and it's going to take you there. A different type of bar chart. So say, why are we doing a second one? Well, look and guess. These are the method of travel to UNSW. Again, we ask students how they come to UNSW. And in that case, see here, the mode of transportation, there's no order, right? These are just bins. So all the people who come by car have been put in the same bin. So I can really permute those. And in that case, what we decided to do was to order them. So you have your bar in a special order, and that makes it a little bit more readable, because right away by looking, you know what mode of transport is the most popular and which one are not used very much. I'm really disappointed. I come by bike. I think it's environment friendly. You take fresh air and so on, but obviously not people's favorite way. So it can make things more readable, right? And it's a categorical variable, so you can swap the columns if you wish. So sometimes, so this is just to give you the hint that there are cases where actually you maybe should swap the columns to make things more readable, to prove your point. So earlier, when we looked at variables, quantity variable, we said that a good way to describe them was to give some indication of the location, you know, where the values are and how spread they are. And that's why when we try to get some numerical summaries, we were looking at the median and the mean for location, and interquartile range and standard deviation for the spread. And now we would like to see that these are still the important features. So when we look at our graphs, that's something we still want to be able to talk about. So use a graph to do that. The fact that we're discussing graphs in the context of a class maybe gives you the impression that the goal is to get the graph, but usually you get the graph to get some information. So just drawing the graph is never the end. What you want is to be able to comment on the graph to say what you see from them. So there's a very interesting link between the graphs and the location. So let's see that on our next slide. So maybe you remember that the mean satisfaction rating with UNSW was 7.35, and we can draw this on a histogram. And on this histogram, this is actually the mean. So the mean is, 7 point something, right? So there is a physical interpretation of the mean. It would be the center of gravity of the data. So if you imagine that this can move this way or that way, basically it's pivoting, and the mean is the point of balance. And I would say I sometimes even use that to check my calculation for the mean. For example, if I do a calculation for the mean and I get that the mean is there, clearly the thing is going to fall down this way. So I know that this is wrong. So this can give you an intuitive idea of what the mean is in relation to the graph. It's the center of gravity. And you can watch this nice little video which illustrates that. So now we're getting to the point where we're going to be dealing with how to do all of this in RStudio and using the ages of randomly chosen students. And I'm not going to do it now because this has been done in a video in the weekly online lesson. So all of these are really what you have in those. So I will just skip all of that, and because you will go through them in a lot of details in the weekly lessons. And you may think you already know everything you need to know about box plot because, I did that in high school. But please, if you look at this example, note that because of this and that, the end of the whisker cannot possibly be the mean and the max, because the mean is this one and the max is this one. So the good question is, how do you define the end of the whiskers? And it's not either, so for example, this whisker, so that would be Q3. It's not Q3 plus 1.5 times the interquartile range. Sometimes it is, and sometimes it's not, because the end of the whisker needs to be a value which is actually in your data set. So I'll not tell you what it is exactly. I'm just telling you, if you don't know exactly what it is, then you absolutely need to watch those videos. Because, and conveniently, not everybody do the box plot in the same way, but we'll stick to what R does because it's a really good idea to separate the outliers from the rest, and we want these whiskers to end at a value which is actually in our data set. So once you have the graph, you have to look at it and describe it. So when you're going to be commenting on a graph or a quantitative variable, there are really two things you need to talk about. As we said, the location, where most of the data are, and the spread, the variability in the data you have, and the shape. And also it would be good if you can indicate if there are any values which are very different from the general pattern, and this would be called suspected outliers. So what we mean by location, for example, you can see that this graph is, if you like, located towards higher values than this one, right? The two histograms have a different location, so they would have a different mean and a different median. This is what spread means. The blue one, the turquoise one, is less spread than the pink one. So it's, histogram, for example, give a good way of commenting on spread. Now the shape, this is symmetric. So beware, this is stats. We're going to say that something is roughly symmetric, even if it's not perfectly symmetric. Shouldn't tend to discuss symmetric as soon as it's not perfectly symmetric. That would be considered left skewed. So something which is reasonably symmetric, even if it's a little skewed, would still be treated as symmetric. So left skewed, or skewed towards the left, means there's a long tail on the left, so it's not unusual to observe extreme values on the left. Right skewed or skewed towards the right, obviously is going to be the other one, where you're going to get this long tail on the right. So long tail on the right, and it's not unusual to have large or extreme values on the right. So there are other kind of graphical tools which we didn't really mention. So there are the stem and leaf plots, the pie charts. So the pie chart, which everybody seems to like in high school, but which don't work too well, and then other kind of graph which you just build for the purpose. So why don't we like pie charts? Well, for example, so let's say you want to look at those and you want to rank the categories by increasing surface. They will represent different things. If you look at that, it really gives the impression that they're all the same. Now, if you were to represent the exact same data using a bar graph, you see much better. Our eyes are much better as distinguishing between different heights and different angles. So in year 7, we made you draw a part chart because we wanted you to use proportionality and calculate angles and use a protractor, not because they were better graphs. Now, if you want to see a fantastic example of a graph which is dynamic and has been created for the purpose, please click on that link and it will show you how the world has evolved over the last 200 years, country by country. So what did we learn? We looked at RStudio, which is going to be our software package, which we'll be using to do stats. We talked about using graph to get a feeling for what for the data we have, and that's called graphical with a graph. Exploratory, trying to get a feeling, analysis. And then we get a graphical summary of what goes on, and we'll learn how to describe the main figures of a data set using a graph.